Bismillahirrahmanirrahim. Today I'd like to talk about the base angle theorem. It's a very important theorem, reasonably easy to understand, I think. Base angle theorem is about isosceles triangles. Isosceles triangles, if you recall, are triangles that have two sides like this that are congruent. Now, as far as triangles go, I think isosceles triangles don't get nearly the same respect as do equilateral triangles. But this theorem is all about isosceles triangles. The first thing I'm going to do is I'm going to state the theorem, then we're going to try to understand it, and then we should try to prove it, and then we'll talk about its converse. So I'm going to write the theorem first, and I'm going to write it as a conditional statement, as we like to do. So, the base angle theorem states, if two sides of a triangle are congruent, then the angles opposite to the sides are congruent. Again, if two sides of a triangle are congruent, in this case like we've drawn over here, then the angles that are opposite to them, like this, are congruent. If two sides of a triangle are congruent, then the angles opposite to the sides are congruent. In fact, sometimes we just abbreviate this theorem fashionably like this. If the sides are congruent, then the angles opposite them are congruent like this. So if you want to say base angle theorem, you just can say like this. If the sides are congruent, then the angles opposite them are congruent. Now, why is it called the base angle theorem? Well, you see, if you have an isosceles triangle like this, these angles are called the base angles. So that's the theorem. Now, what's the proof, you say? That is, how do you know that if those two sides are congruent, how do we know that these two angles are going to be congruent? Well, let's try to prove it. First, I'm going to label this triangle, triangle A, B, C like this. And then we're going to be told here, or we're going to be given here, that AB is going to be congruent to BC like this. So that's the given information. And we're going to prove that angle A is congruent to angle C. That's our job. So given AB is congruent to BC, we're going to prove that angle A is congruent to angle C, and that's what the base angle theorem states. So, when in doubt, begin with what's given. So, the first step here, I'm just going to write AB is congruent to BC. Now, what do we do? Well, it's not immediately apparent, right? It seems like we don't have a lot of information that's given to us to be able to prove this. Well, how are we going to do it, I wonder? Well, this is how we're going to do it, I think. What I'm going to do is I'm going to draw a line starting from right there, from the vertex there, straight down. And I'm going to call this point right here point D over here. And this is no ordinary segment. This is a segment that's perpendicular to AC. Now, I'm going to say over here, draw. Now, this is kind of cool, I think, because you can say draw BD. Because this was not given to us, and we're making a new segment, we have to give a reason why we can actually do this. Now, BD, you understand, is no ordinary segment. It is a segment that's perpendicular to AC. And we can do this because, now this is $1 million question, why can we do this? We can do this because of perpendicular postulate. Now, perpendicular postulate, you recall, states that if you're given a line L like this, and a point P that's not on line L, then there's one line, and only one line, that goes through point P that is perpendicular to this line over here like this. And this is the postulate that allows us to draw this segment. Okay, what now, you say? Well, now you see, and I hope you appreciate that we have created two triangles here. Here's one, and here's the other one. And these are no ordinary triangle. These are right triangles. And then I'm going to say triangle ABD and triangle CBD are right triangles because of definition of right triangles. Okay, so now what? Well, I'm thinking if I could prove these two triangles to be congruent, see? Then I could say angle A is congruent to angle C because corresponding parts of congruent triangles are congruent, CPC, TC. My plan is I'm going to prove these triangles to be congruent. Then by CPC, TC, angle A is going to be congruent to angle C. Alright, so how am I going to be able to prove these two triangles congruent? Okay, well, let's write down all the ways that we know of proving triangles congruent. There's side, 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 side angle, side angle, side angle, and there's angle, angle side, and finally this hypotenuse leg. And this last one is a special case, and we can only use it if we had, wait a minute, we do have right triangles over here, right? So maybe I can use hypotenuse leg to prove these two triangles congruent. Well, to use hypotenuse leg, we have to have a hypotenuse that's congruent. Well, here's a right triangle. Hey, that's the hypotenuse, and they are congruent. So I got the hypotenuse to be congruent, and I need one side to be congruent, right? Okay, where's my side that's going to be congruent? Well, maybe this side is congruent to this side over here. Maybe, well, this side is common to both triangles, right? So, oh, there's my side. See here, I have hypotenuse, and that's my leg over there, so hypotenuse leg. And there we have it. Those two triangles are congruent because of hypotenuse leg. Ta-da! So we're going to do this. But before we can say those two triangles are congruent, we have to state the following. BD is congruent to BD ever since it was born. Why? Because of reflexive property of congruent segments. See, now I can say the two triangles are congruent. So triangle ABD is congruent to triangle CBD, and this, my dear friends, is because of hypotenuse leg. And from this, we can state that angle A is congruent to angle C because of CPCTC. Ta-da! Corresponding parts of congruent triangles are congruent. So there we have the proof. If two sides of a triangle are congruent, then the angles opposite to the sides are congruent. This is a very important base angle theorem. Now, as I suggested, you can simply write like this. If the sides are congruent, then the angles are congruent. But it's kind of cool to just know the name of the theorem, right? The converse of the theorem is also true. If the angles are congruent, then the opposite sides are congruent. That is, if I told you that these angles are congruent, then the sides opposite of them are congruent, like this. That's the converse of the base angle theorem. Now, how would you prove this? Well, I'm not going to write a two-column proof, but I'll give you a hint. How about this as a hint? I'll leave you to prove the converse. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.